All right, Algebra 2, here's part 2 of this factoring business for 4.4. Example 1 still, we're just going to practice this factoring as much as we can, okay? This part C is going to show us that we don't have to always apply the steps, okay? So, and let's see why that is. So step 1, we need to factor out our GCF. This one actually does have one. 2 to 24, everything can be divided by 2. So let's factor out a 2. 2 divided by 2 is 1, m squared. Negative 2 divided by 2 is negative 1, m. Negative 24 divided by 2 is 12. Oh, okay, cool. So now if we look at the inside of our parentheses, we have a good old 4.3 quadratic. We don't have to worry about applying the steps we learned above because our leading coefficient is 1. So let's just factor, because we can get away with it, let's just factor how we normally do, right? What's a factor pair of negative 12 that's going to add to negative 1? Pause the video if you want to think about it, but it's going to be negative 4 and positive 3. Boom. Okay, and make sure that this 2, you factor it, whenever you factor it out, you're not throwing it away. Look how I carried it down every single time, okay? And it's going to be in our final answer. The GCF does not die unless we're solving equations, and we'll talk about that when we solve equations, right? But when we factor, the GCF stays along for the ride. Don't get rid of it. Okay, that wasn't too bad. Let's go to the next one. Part D. Now this one is going to show us that we don't have to, we don't always have to factor like we're used to. Sometimes we just stop at step 1. And you can probably tell that, yeah, here we're just going to stop at step 1. Factoring out our GCF. What is our GCF here? 3 and 25, they don't have any factors in common except for 1, but there's u squared and u. So I can factor out a u. Oh, sorry, didn't grab my pen. I can factor out a u. From the first term, I'm left with 3u. Second term, I'm left with just 25 when I divide out the u's. And here you're done, right? I'm kind of covering my bases because this is something I didn't exactly cover in 4.3. So I want to make sure we're all on the same page going forward. Whenever you see just 2 terms like this, you're either doing, it's either going to be a difference of squares, which we'll look at down here in the next few examples, or it's going to be the case where you're just only factoring out a GCF, okay? Next example. We have part E right here, good old part E. So then let's apply the first step, factor out the GCF. Usually you can tell what you need to do for the rest of the problem once you factor out your GCF. What's our GCF here? 6, 14, and 8, it looks like it's going to have to be. And now here, to make our lives easier, we never want the leading term to be negative. So let's go ahead and factor out, not just a 2, but a negative 2. Negative 2, remember, it stays along for the ride. Negative 6 divided by negative 2, that's negative 3, y squared. 14 positive divided by negative 2 is, ooh. Why didn't anybody correct me? Just kidding. 14 divided by negative 2 is 7y. Negative 8 divided by negative 2 is positive 8. I did it right this time. No, I didn't. I did the sign right, but I didn't do the division right. Algebra 2, one day you will get a math teacher that knows how to do math. Until then, you're stuck with me, okay? So let's go ahead and let's take a look at what we have left in the parentheses. 3y squared minus 7y plus 4. So here, we don't have a 4.3 quadratic, we have a 4.4 quadratic. Leading coefficient is leading coefficient is 3. And it's not, it's not 1. So we got to apply our steps here in order to factor this thing. So again, we're going to take our A times C. In this case, it's 3 times 4 That's 12. So factor pairs of 12, 1 and 12, 2 and 6, 3 and 4, that add up to -7. Positive, so they're the same sign. Negative, so they're both negative. Which is going to give us a -7. When we add them together, it's our -3 and -4. Okay, so we can separate. -2 stays along for the ride. 3y squared minus 3y minus 4y plus 4. Maybe a question that has popped up in your head, hopefully, is does this order matter? Could I do this as -4y and -3y? Switch the order around of the middle two terms that I just separated into? The answer is it doesn't matter. You can go ahead and choose whatever order you want. You'll get the same thing, right? So if you want to convince yourself, once we finish this, you can start back over at this step, switch them, and see if you get the same exact answer. You should, right? Okay, so now this is going to get a little chunky, a little messy, because we need to do our factor by grouping insights in parentheses. So -2. And so I'm going to turn them into brackets just so it's easier to tell. We're grouping our 3y squared minus 3y minus 4y plus 4. Here's our first group, and here's our second group. What can we factor out of the first group? They both have a 3, they both have a y, so a 3y. What am I left with? Y minus 1. Plus, always put this plus here. I have a negative here, so I'm going to want to start with a negative. What do we have in common here? A 4. So we're factoring out a -4. What are we left with? Y minus 1. Almost there. Last step, factor out. We have two terms again. Factor out the GCF between these two terms. The GCF here is y minus 1. So I have -2. I can drop the brackets now because I'm about to be done. Y minus 1. I have left 3y minus 4. And there's our beautiful, beautiful answer. All right, hopefully that sounds okay. Let's do a few more. I hope you're not tired of factoring yet. We still got, we're gonna see this for a few more weeks. Sorry, we're gonna see this for one more week, and you'll see it again on your checkpoint. So start making friends with factoring. 9x squared minus 64. Here, we're gonna try to use our special patterns, okay? So our special patterns, if you remember, the one that this looks most like is a squared minus b squared. And remember, that's gonna equal a plus b, a minus b. And the reason why we're doing this here while we're using our special patterns is because if you notice, 9x squared and 64 are perfect squares. This is the only time you're gonna use your special patterns, when you see perfect squares in the ax squared term and the c term. If you see perfect squares in those terms, you might wanna try using a special pattern, okay? So if I know a squared is 9x squared, I want to ask myself, what did I square? What times itself gives me 9x squared? Well, what times itself gives me 9? That's 3. What times itself gives me x squared? That's x. Same idea with b squared. What times itself gives me 64? 8. So now I just got to plug it into this pattern, and I don't have to do any more work than that. 3x plus 8. 3x minus 8. If you wanted to, you very well could have used the steps we talked about earlier, but work smarter, not harder, right? If you're comfortable with these patterns and they make sense to you, I would definitely use them because this will definitely save you time, right? Now, if you're still kind of like, oh, this pattern don't really make sense to me, Mr. G, go ahead and continue factoring using those steps the way we have, okay? one last example of factoring, and then we'll talk about something a little different, not like hugely different. We're still going to factor for the rest of this, for the rest of these videos. Same idea here, but remember, what's our first step? Let's factor out a GCF. I kind of cheated in the previous example. We didn't factor a GCF out. There wasn't one, but it's always good to make sure you check. GCF, not GOF, GCF. It's not gonna let me erase it. I have to select it and throw it away. There we go. Our GCF. What goes into all of these? It looks like it is 4, oh, not 4, 2. Factor out of 2, we get 9z squared plus 12z plus 4. Okay, look at your first term, your z squared term, and your constant term, your ax squared and your c. Those are perfect squares. And this looks a lot like the pattern a squared plus 2ab plus b squared. And that's going to factor to a plus b times a plus b, or a plus b squared. So now you have to be careful though, because you have to make sure it lines up exactly. So the next step we have to do in order to make sure that it does is make sure that 2ab is 12z. And to do that, we need to first find a and b. So a, what is a going to be? That's going to be 3z, because 3z times 3z is 9z squared. B is going to be 2, because 2 times 2 is 4. So now let's calculate 2ab. We have 2 times 3z times 2. 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12. Times z is 12z. So it's a perfect match. I can cheat. I can use this shortcut to just write 2, 3z plus 2 times 3z plus 2, or 2 times 3z plus 2 squared. Okay. Use the shortcuts if you can, guys. If this is too confusing, then this one as well. From here, you could have factored using the steps. Okay, whatever makes more sense to you, I am totally fine with. All right. See me in the last part of this video where we're going to solve some equations.